Okay, for number 1, is this direct, inverse, or neither? We have to read this. So we're looking at each x and each y. If we were thinking, let's decide that first. Do we think it's direct or inverse? Inverse. Inverse, okay. So if it's inverse, if I were to multiply these, each one, if they give me the same thing, it's inverse. So negative 2 times 1, 3 times 0, that's already not the same, not inverse. So then let's try direct. If we divide y by x, so for this one, 0 divided by 3 would be 0 still. 1 divided by negative 2 is negative 1/2. Again, not the same. So it's not direct or inverse, it's neither. Questions, sir? Okay. Number 2, if we were to factor this, let's first start with GCF. Do they have anything in common? X. They both have an x, so I could factor out a negative x because this first one is negative. So if let me rewrite that. If I'm dividing x from both of these, what would be left? Negative x squared plus 12. And then I have 2 terms left, so I can either use GCF again or this minus. Or difference of squares. Is 12 a perfect square? No. So then, can't use that. Can I divide anything else out of these 2? No. So this is your final answer. Questions? And then number 4 on the solve for r. So we have to get r by itself. We can get rid of pi by dividing both sides. And then how would we get rid of the square? The square root of both sides. If this were a real problem that we were solving for square roots, it would be plus or minus, but not in this case. So then this would be our answer. The square root of a over pi equals r. Questions?
I thought it was all together, so
So I'll just show what happens if we do that. So if we square root have the square root of a equals the square root of pi, and we have to separate those, that one would just become r. And then we still have to divide by the square root of pi. And then this, you actually have to rationalize the denominator, which is not something I'm going to show right now. Okay. Other questions on that? Okay. We'll briefly start this. So you need your calculators, go grab that. Okay. We have to think about our transformations, shifts, translates, it moves up or down or right or left. Reflections, if it reflects over the y-axis or the x-axis, it flips. Stretches, we're mostly dealing with vertical stretches, so and compressions. It either gets wider or it gets narrower, depending on the number. And yeah, okay, that'll be good. But then we also have to remember what the parent function looks like. So there are 2 that we're talking about, the quadratic and the absolute value. And we have to remember where those start. So I'm going to draw that one of them. If you have your notes from the last lesson that has all the different transformations, you may want to take that out also, just so you can have something to refer back to. But our goal in today's lesson is going to be to take this graph, write the equation for it. So one, we need to know how that equation is going to look. It's going to either look like one of these. So you can put f of x or y equals, for your quadratic, a parentheses x minus h, n parentheses outside squared plus k. Some things to remember about this. Your A shows where your vertical reflections would be, where your vertical stretches and compressions would be. Your A value would change. Your H is going to be your horizontal shifts, moving left or moving right. Whatever number is in there does the opposite. And then the K on the outside is your vertical shift up or down, and that does exactly what it's supposed to. I'll do the absolute value when we get back. So, parent function, the original, if we don't remember, we can always put it into the graph. I don't even know what that is. It's a U shape, so that would be your x squared parent function. So put that into your y equals. Go into your table. Find the middle. So look for where your y values repeat and find the middle. 0, 0. So my original parent function starts at 0, 0, and then I can plot the other points. Negative 1, 1, 1, 1. Negative 2, 4, and 2, 4. The negative 3, 9 and positive 3, 9 would be off the graph. So this is really all I need right now. So if I'm comparing my original to what's already there, what happened? It moved to the left twice. So that's going to be something with h. That's going to be the only thing that changes. So I can put f of x equals, our a value is just going to be 1. I'll leave a space. We just have to figure out what that h would be. So if I put minus 2, that would tell me it moved to the right. So I would have to put plus to tell me it would move to the left. Because really that would mean there was a negative 2 in there, and the negative and the minus became a plus. And if I check that, if I type that into my calculator, it should do the same thing, move to the left. So you're going to use your calculator a lot to double check whatever you're writing, because if what you wrote doesn't match the graph, then it's fine. And we'll do some more of those when we get back to lunch. Horizontal shifts are h, so we had to put in a number that would move this to the left, and this is always opposite. And then I said to put this back in. And if you graphed it, you would see that this is identical to this one. It did move to the left. If I put in minus 2, it would do the opposite. Because then it would move over here, and that's not what we want. So be using your calculator to double check yourself. I didn't do this before we left, but I wrote it afterwards. If writing this helps you write whatever goes in here, also do that. You don't have to, but it is good practice to remember what the transformations are. Okay, let's do one of the absolute value ones. I'm going to write the function first. So it's going to look very similar. In general, your function would be f of x or y equals a times the absolute value of x minus h, and then on outside of that plus k. So just like we did for this one, we have to recognize that this is a V, not a U. So the V is going to be your absolute value. I'm going to I tried to mix those words anyway. The original to see what happened, what changed. So I'm going to clear out both of these. And in the first one, I'm going to put alpha window to get that absolute value. So alpha window and put X in between. Go into the table. And just like your quadratics, find where your y values repeat and find the middle. Yes, in 1 second. After this problem, where it is. Or within the middle, 0, 0. What's nice about our absolute value is whatever the number is, negative or positive for the x, whatever the y value is going to be the same. So once you have one side, it just repeats on the other. Now, the one I have drawn and the one that's there, I have more points drawn, but if we continued those lines, it would do that. So what happened here? What changed? It moved left twice. Just like this one. So the plus 2 is going to be the same, but then we're using this. How would we write that equation? Here, one away. Use one away.
I think x equals 1. Absolute x plus 2.
Absolute value of x plus 2. And if I were to graph that in my calculator, again, I didn't write this, I'll write that afterwards. And I'll go back to that in 1 second. In the next line, I'm going to put alpha y equals, alpha window, the absolute value, x plus 2, and graph them both. And I see my original, and I see my other function was moved to the left twice. So really what you need is the function. The graphing, the original, you don't have to do, but if that helps you see what exactly happened, you can continue to do that. And you also don't need to write the transformations that happen, but if it helps you write that equation, then you can continue to do that. Questions so far? Okay, we're going to move on to 3 in just a second.
Oh, yeah.
Who's your
Hard bet.
because
Hard. No, I'm just saying, but you're gonna give me ball.
let's go. Party.
I don't know.
Who's other Luis? Luis been
I
blocking.
don't know. I don't know who I'm gonna go.
Make sure that's fine. So
I'm
I'm
gonna
going to
go
write you an equal pass.
Did you email?
I'm going to write you an equal pass. Who's your concept?
Hmm?
Who's your concept?
This whole. Yeah. Salvador con Gaby.
No. Okay, go, come right back.
Alright.
I'll tell you more.
Okay, first, which type of function is this? The quadratic, the U shape, or the absolute value, the V shape? The V shape, the absolute value. Okay, so we know we're going to be dealing with this. Off to the side, I'm just going to put the absolute value of x, so we know which one we're dealing with. That way, when we write our equation, we don't confuse it. Now, you can redraw, okay, I keep mixing up those words. This parent function, the one in red, on this, if you so choose. You don't have to. I'm just going to point back at number 2. Looking at this red graph and looking at number 3. what do I see change?
It's upside down.
It's upside down, so it flipped. It's a vertical reflection. Anything else that we can see happen?
Movement.
And move up how much? 4. So I can look at the vertex point and see that it was at 0, 0, and it was flipped. And if it was just flipped, it would still be there, but just upside down. But then it also moved upward. So we're gonna check ourselves in the calculator after we do this. But we have 2 things that are vertical. So that's gonna be something, that's gonna be an A. Your vertical reflection is gonna be something that changes your A value. The vertical shift up 4 is gonna be something that changes your K value. So then when we write this equation, it'll look similar, or it'll look like this. But how would we write the A part if it's a vertical reflection? How would we show that?
Would it be -1?
So f of x equals -1. Write that like this. And then
Absolute X.
value of just x. We don't have an h. It didn't move left or right. So just absolute value of x
Would it be +4?
and then +4. You could also just write this as negative absolute value of x. So either or. Questions so far?
Wait,
Yeah.
does the -1 mean it's upside down?
Yes. The -1 or just the negative out front means it flipped upside down. Yes.
Does it matter which one you put?
Both of these would be right.
How would it reflect across the y-axis? What would that mean?
If it reflected across the y-axis, that's a horizontal reflection, and that would be on the inside. But it's hard to see that from right here. I can say that happened, but it didn't move left or right, so you can't really see it. Things like that, you wouldn't get taken off for, because it could have happened, it could not have happened. I'm going to put this in just to make sure that we wrote that correctly. And you can look at the points if you graphed it, or just the graph itself. And this red one is flipped upside down. It is moved upward. If I look back at this, it looks the same. Other questions before we move forward? Which type of function are we dealing with? The quadratic or the absolute value?
Quadratic.
Quadratic, the U shape. So that's your x squared. And compared to this original, if you want to draw this on here, you can. Compared to this blue, darker blue one, what happened? What changed? It moved right how many? 3. And then up 1. So it moved to the right 3 and moved up 1. So the right would be which of these variables would it change? A, H, or K?
K.
K and H. Which one would do which?
K would be 1, H would be 3.
Right? And then we can start to put those together. F of x equals 1. So not absolute value because we're dealing with x squared here. Plus
X plus 3.
x plus 3
Minus.
minus 3 because it's opposite. squared on the outside
Plus
plus 1. Yes.
Does this square ever do anything, or is it just?
It just shows you that it's making this. So if I took this square out, it would make a line instead of the U shape. So always make sure you have the square. If you change it to something else, the function changes. We're going to put that in just to make sure that we have that. Instead of getting rid of everything, I'm just going to keep that, but move it down. What did we say? 1 x minus 3. Whoa. Square. Oh, except I didn't put plus 1 again. Now that happens, it moved to the right and it moved up. So you will have your calculators. You'll have to write your equation, but there's nothing stopping you from putting it back in and double checking. We're going to skip around. Let's do 6. Which type of function is that?
absolute.
Absolute value, because it's making the V shape. Now, just because mine is further up, I'm going to redraw my original. You don't have to, once you get the original in your mind, or if you look at it from a graph, you can just kind of picture it, visualize it. But what changed between these two? Okay, upside down, it's down 4. 1, 2, 3, 4, 5 actually, but so it had a vertical reflection because it flipped over the x-axis. It vertically shifted down 5. Did anything else change?
It's like wider.
It is wider. So the wider would mean there is a compression happening. To figure out that compression, these lines work just like so. Okay. These lines work just like slope. Start at the vertex and count what that slope would be. So if I started here and counted here, what would that slope be? -1/3. But the negative we already got with the reflection, so we just need the 1/3 part.
So we replace the one with the parentheses?
Say that one more time.
It would replace the one before the parentheses.
The negative would, but also so would this, yes. They both would. So then we have the vertical reflect would be part of the A, but so would this. So those would go together. The vertical shift down 5 would change which variable? K. So how would we write that function?
That would be -1/3. Absolute x. Then one's 5.
Times 5. So -1/3 times the absolute value of x minus 5. There were no horizontal changes, so nothing goes inside.
Would the flip of the figure, would that cancel out with the negative from the slope? And figuring out if it was compressed?
Not really cancel out, but because even if it was, I was trying to answer two different things. So if I'm counting the slope, this part is -1/3, but if I counted it from this part, it's a +1/3. So one, it depends on which side you're counting it from. But two, if it's flipped upside down, the negative is already accounted for. It's there already. You don't have to put it twice. Okay, let's look at 7. Which function is this?
Quadratic.
Quadratic. So that's your x squared Again, I'm just gonna redraw the original just because it was further up. When we get to the graphing piece of this, I'll show you tricks to remember how to graph this, but for now you can keep using your calculator. What changed? It's upside down, it flips. That's your vertical reflection. Anything else? Is the vertex at the same spot? And up 2. So that's your vertical shift, up 2. And then, yes.
Can we look at my phone?
After we finish this here. And then look at the distance between, on the original, from the first to the next point, and then the one that's drawn, from the vertex to the next point. What's that distance? It is a stretch. By how much? It's 2. So when looking for that stretch or compression for your quadratic, you look at the distance between the vertex and the next point. That'll tell you what that is. So then we're going to have an A and a K again. How would we write this function? X equals negative, it would be negative 2 in this case. Parentheses, or you don't really need a parentheses, sorry. You can put it if you want. And then your K value, plus 2. So you can put it like this, or without the parentheses. Either way would be fine. The only time the parentheses absolutely matters is if you have an H value. So we did a vertical compression. Let's do 8 and 9, and then I'll let you guys try some. So 8, what's going on there? What function is this first? Quadratic x squared. Abir, go ahead. Who is your counselor? Who is your counselor?
Miss Snow.
And then compare that to the original we drew in 7. What changed? It did move to the left. Okay, let me finish this and then I'll write that.
Where's Caleb? Right here.
Okay, it did move left, so that would be horizontal. And what is it, 3?
Yeah.
And up, which would be vertical. It is reflected. Oh, that is reflected. And it's compressed because it's wider. Now this one is a little different because we're still looking at that distance. But it's going to be like 2 by 2, and it's not, you don't simplify that to 1. You still think about it as 2, but because it's a compression, that's going to be a fraction. So it's going to have 2 in it, and it would be 1/2. You could also points. If the distance is now times 2, from here it was up 1 and then up 3, and then when we multiplied it by 2, it was down 2 and then down 6. So that 3 distance multiplied by 2 became 6. Same thing should happen here. That distance is now 6. So that could help you figure out that number. So we have a bunch of things that's going to change. We have an H, we have a K, we have an A, but 2 things are happening to A. I'm not going to write which ones are which for this one. What would that function look like?
F of x equals -1/2.
Mm-hmm.
Parentheses x plus 3 plus 4.
X plus 3 squared on the outside, and then plus 4x. Really, with your quadratic compressions, I would double check it in the calculator because your absolute value is really easy to count the slope. Quadratic, you might get confused. So I'm going to double check that one in the calculator. And then here you can ask your question after this. So that was -1/2 x plus 3 squared plus 4. So I can see it definitely got wider, it's upside down, it moved left 3, and moved up 4. You can also look at the table. Yeah, what was your question? Yes, after we did this next one, yes. Do we have any questions so far? Yes.
So, for that specifically, would it be 2 to 10 to 1 now? Or would that have to go like a bigger number, like 12?
I missed the first part of that call. Repeat that first part.
So, since this is
Louise,
originally
slower.
2 and then 2, which is the fraction for the A, that only translates to 1/2 now, or would that translate from like 4 before to 1/2 again?
It depends on if this is if it got wider or not. If it gets narrow, you would not change it. But if it gets wider, whatever that distance is, becomes a fraction. Okay. And number 9. What function is that? Absolute value. Okay, think back to how we drew the original absolute value. I'm not going to redraw it again. What changed?
Getting to the left and then down. Forward to the left one.
Okay, move to the left 1. Horizontal shift, left 1. It went down 4, so vertical shift. Did anything else happen? It got thinner, so that means what? Stretch, vertical stretch by count the slope to a ruler. So then how would we write that? F of x equals,
2
just leave it as simplified as possible, so just 2.
absolute x minus 1.
X minus or plus? It would be plus. So whatever it says or whatever you're thinking, left is usually negative, but do the opposite, put plus. And then
Minus 4.
minus 4 on the left side. Okay. Questions on that one? Okay. I want you to try, I think there were 2 that we didn't do, or maybe it was just 1, 10, 5, and 10. I want you to find the function of that, and then after you do that, raise your hand and I'll come check it.